Welcome to the Deep Dive, the place where we take complex source material and turn it into actionable, memorable knowledge just for you. Today, we are plunging deep into the world of software development, specifically how artificial intelligence is fundamentally revolutionizing the critical process of code review. We're moving way beyond simple static analysis here. We're talking about AI that provides contextual, truly actionable feedback.
It's a massive shift. Code review is arguably one of the highest leverage activities a developer can do. It improves the team's code quality and, at the same time, levels up individual skills. We've gathered some fascinating sources for this: technical guides, empirical research from huge players like Google, and some really clear best practices for integrating AI into your workflow.
And our mission today is to give you a shortcut to understanding this transformation. It's not just about what an AI can find in your code. Crucially, it's about what kind of feedback developers actually want to receive. The whole thing hinges on getting that human-in-the-loop approach right.
Exactly. And, we should start with the foundation. Before AI, the data on human peer review is just incredibly strong. For instance, code review has an error detection rate somewhere between 55 and 60%.
55 to 60.
Yeah.
How does that stack up against, say, automated testing?
It blows it out of the water. Unit testing, for example, is usually around 25%. Function testing gets you to 35%, and integration testing maybe hits 45%. So human peer review is just demonstrably superior at finding defects.
And the impact is huge. We looked at one study that showed before formal reviews, you'd find about 4.5 errors per 100 lines of code.
And after?
After implementing reviews, that number just plummeted. It went down to 0.82. That's an 80% cut in defects. The foundation of quality really does start with the human eye. Given those numbers, I would have thought finding bugs was the absolute #1 goal of code review. But where does the source material rank that?
That's a great question, and it really gets to the core of how teams function. One source frames this as a hierarchy of needs for code review, and finding bugs is high up, for sure, but it's not the foundation.
Okay, so what is?
The single most critical function, the base of the whole pyramid, is mental alignment.
Mental alignment. That makes so much sense. It's about keeping the whole team's understanding of the system up to date as it changes. If I review your change, I'm not just looking for errors, I'm updating my own mental model of the code.
Precisely. It turns the review process itself into a knowledge transfer mechanism. After mental alignment, then you get to the other high-value things: verifying the correct solution, enabling design discussion, and then finally, finding bugs.
And what's at the very top of the pyramid? The least important thing for a human to do.
Style. Things like code formatting and consistency.
Right. Style is important for readability, but you don't want a human spending their valuable brain power correcting indentation. They could be catching a major bug instead.
Exactly. That part should be automated, which is why AI is so perfect for it. But when humans are reviewing the complex stuff, our sources point to 5 key technical areas they really focus on.
Okay, let's detail those. The first one is pretty obvious: logic and correctness errors.
Right. This is catching things like, accidentally using the is operator for comparison instead of in Python. It's a tiny difference, but it can lead to some really subtle, hard-to-find bugs at runtime.
And then there's readability and maintainability. Just making sure your teammates can understand what on earth you wrote.
Yeah, if the logic is tricky, a good human reviewer will push the author. They'll say, hey, maybe extract this into a helper function to make it clearer for everyone.
Third is performance. This is a big one. It's so easy to write something that looks fine, but is secretly really slow.
For sure. A classic example is having repeated lookups inside a loop, which gives you that ON2 complexity. A good reviewer spots that and suggests a better data structure, like using a set, which can make it drastically faster.
Fourth, security. This is critical.
Yeah.
Are you using dangerous functions?
Absolutely. The sources really hammer this point. Avoid things like using eval on user input. That can execute arbitrary code. Instead, you should use a much safer alternative like alice.literal eval. That one change can prevent a massive vulnerability.
And finally, enforcing project best practices. These are the unique rules for your team.
Exactly. Like ensuring all data access goes through a specific caching layer, or always using a standard user id for lookups.
Okay, so that foundation is solid. We know what humans look for. Now, how does this new AI stuff actually work? What are we really talking about when we say AI code review?
We're talking about the deep integration of machine learning and natural language processing. These tools analyze code for all those things we mentioned: bugs, security flaws, performance, style. But the crucial difference from older tools is context. Modern AI understands the context of your code, the whole repository, even your documentation. So it doesn't just flag a problem, it can suggest or even generate a real fix.
That contextual understanding is the game changer. It turns a simple linting error into a meaningful correction. What are the big measurable benefits teams are seeing?
Well, they really fall into four main categories. First, increased efficiency. Automation just cuts down human review time. Second, consistency. The AI applies the same high standard to every single review, no exceptions, no human fatigue. Third, reduced cognitive load. The AI handles the routine stuff so human reviewers can focus their brain power on complex architecture. And finally, knowledge sharing. Developers learn best practices right there, in the moment, from the AI's suggestions.
So if you're a developer listening to this and you want to start integrating AI, what are the first practical steps?
You need a structured approach. Step one is choosing the right tool for your team. You've got specialized tools like Deep Code for security or Graphite agent for contextual analysis in your PRs, or even GitHub Copilot right in your IDE. You have to choose based on your programming languages, your existing tools, and how much customization you need.
It sounds like it could be a heavy lift in terms of configuration.
It can be, but it's essential. Step two is defining your review policies in config files, setting severity levels, focus areas, that sort of thing. And then critically, you have to train your developers on the tool. They need to understand what the AI is good at, and just as importantly, what it's not. And this is where it gets really, really interesting. We move from the tech to the human factor. The biggest challenge when you deploy an AI reviewer isn't its ability to find issues, it's developer acceptance of the type of comment it provides.
Right. If the bot flags something a human would let slide, like a perfectly readable list comprehension, developers are just going to mute it.
Yeah.
So how do you draw that line between helpful and just plain pedantic?
That's the core challenge. The research actually maps this out using a quadrant. It's based on two axes. Can an LLM catch it, and do humans want to receive it? The goal is always to be in what they call the gold zone, which is the top right.
So what's in that gold zone? What's the sweet spot?
That's where AI succeeds, and humans welcome the feedback. Simple bugs, performance issues, security flaws, edge cases, documentation gaps, and style consistency. The AI is super consistent and fast at these, and developers appreciate getting that immediate, objective feedback.
Okay, so what about the things LLMs can't do well but humans really value?
That's the human-only zone. This requires really deep, specialized knowledge, things like tribal knowledge, that institutional memory that explains why your team never uses a certain pattern, even if the code looks fine, or really nuanced business logic that an AI just can't grasp. An AI can't pull up that 5-year-old wiki page explaining a past failure, but a human can.
And then there's the one that kills trust, the annoyance zone.
Ah, yes, the top left quadrant. These are issues LLMs can technically find, but developers find them pedantic and frustrating coming from a bot. Suggestions about abstract best practices, general code cleanliness, or demanding you add a test when it's not really needed. A human has judgment, a barometer. A bot might just apply a rule universally and generate a lot of noise.
So, with all that in mind, why is human reviews still so essential? I mean, the AI accuracy for common issues is pretty high, right? 70 to 90%.
Because the human reviewer still owns the final decision to merge the code. The AI is a fantastic tool for efficiency, but it can't replace those essential human tasks. Humans are indispensable for architectural decisions, validating complex business logic, and dealing with all those ambiguous subjective issues. The human-in-the-loop approach is completely non-negotiable. The AI has to be a complement. It amplifies human expertise. It doesn't replace it. And moving from theory to practice, we've got some fascinating real-world data, especially from Google's large-scale system, Auto-Commenter.
What's the ultimate metric for whether an AI comment is effective? It has to be whether the developer actually acts on it, right?
Exactly. It's the actionability metric. Did the developer change the code based on the comment? And to set a baseline, you have to look at the human benchmark, which is really surprising. Only about 50% of comments left by human reviewers lead to a code change in that same PR.
Only half. That seems really low for such a core process.
It does sound low, but remember, the other half might be fixed in a later PR, or they're just suggestions the author disagrees with. So the goal for the AI was just to match that human efficacy, and they did. By tuning their models specifically for this task, they achieved a 52% action rate. The AI was just as good as a human at prompting necessary changes.
That's genuinely surprising that a machine can match a human on a complex behavioral metric like that. How did Google actually manage to roll this out? What were the hurdles?
They used a really disciplined, iterative process. At first, they set an incredibly high confidence threshold, like T0.98, to make sure there were almost no false positives. But that meant the AI was too shy. It didn't comment enough. So they fixed this with per URL thresholds.
Wait, per URL, what does that mean here?
It means instead of one high bar for everything, they could tune the confidence level based on the specific best practice rule being referenced. A security rule might keep that 98% confidence level, but a less critical style rule could be tuned down to 95%. It made the whole system much more adaptable.
And what about that trade-off between speed and the quality of the AI suggestions? You mentioned real-time versus PR reviews.
Yeah, that's a classic trade-off. For the code review system that analyzes pull requests, they used a method called beam search. Think of it as letting the AI explore many different paths to find the absolute best, most insightful comment, even if it takes a bit longer. This tripled their posting frequency.
You can't have that delay when it's real-time in your IDE.
Exactly. For the IDE integration, you need instant feedback. So there, they switched to greedy search. It just gives the quickest, most immediate answer. It might not be the most creative, but it ensures sub-second latency so you don't break your flow.
And maintaining trust must have been a constant battle, especially if the best practices themselves change over time.
It was crucial. They found that if the bot kept recommending an old Python syntax, for example, it would quickly erode trust. The solution was a dynamic suppression mechanism. They could immediately filter out predictions linked to deprecated or known low-value rules.
Which ties right back to that annoyance zone. How did they actually get developers to like the bot?
Well, initially, the useful ratio was only 54%. After a deep study, they realized a lot of the suggestions were just too pedantic. So by strategically suppressing 17 specific rules linked to non-actionable or overly subjective warnings, they raised that acceptance rate to over 80%. By saying less, the tool paradoxically became more useful. It eliminated the noise.
So what does this all mean for you, the developer, writing and reviewing code today? We need a clear set of best practices for this human-AI partnership.
The focus has to be on elevating human feedback. For reviewers, that means constructive feedback. Avoid vague comments like, "this won't work." Be specific, reference project rules, and always suggest alternatives.
And I think framing things as a question is such a powerful technique.
It is so effective. Instead of saying, "you forgot to handle negative numbers," you ask, "how does this code handle negative integers?" It encourages the developer to find the solution themselves and maybe even add a test case for it.
And with AI getting better at basic security checks, how does that change the human's role?
AI is not a substitute for human diligence. The human reviewer owns the decision to merge. Any security-critical code, anything touching user input, authentication, databases, it has to be carefully verified by a human. The AI is a great first pass, but the human is the final gatekeeper.
And what about for the person submitting the code? What's the best way to make the review process smoother?
Review your own code first. A self-review is crucial. Leave comments on anything non-obvious to guide your reviewer, and keep your changes small. Scalpel-driven development, not a giant machete change. Small, digestible chunks are just easier for everyone to review.
And finally, building that trust between the humans in the loop seems key to making this whole thing work.
Absolutely. Authors need to be gracious. Acknowledge the feedback, even if it's just with an emoji. And if you agree to fix something later, follow through. Link back to the original comment when you fix it. That one action builds incredible long-term trust with your reviewers.
So that wraps up our deep dive. To sum up, AI excels at consistency, volume, and catching those routine issue-style basic bugs. But humans excel at context, architecture, and applying that essential tribal knowledge that really makes a team successful.
And code review is more important now than ever, especially in an age where AI can generate huge amounts of code so quickly. We have the data now. A well-tuned AI is already as effective as a human at prompting necessary changes in your code.
So here's our final provocative thought for you to chew on. Since AI is successfully automating those lower-level checks, what high-level architectural discussion points are you deliberately carving out time to focus on during your next code review that the bot simply can't handle yet?